the I call the Plonky3 FRIPCS row horizontally and then row vertically. And my friend Qi call it mixed degree FRI. Both capture the core of this type of FRI. Row horizontally and vertically describes the main process, and mixed degree FRI states the main property. It means it can batch mixed degree polynomial. Okay. First, prover will commit the input polynomial to verifier. Okay, let me write here. Prover verifier. Input polynomial, I would 一个括号吧。Send the commit to verifier. Then verifier will choose opened point Z. Then and the random number alpha used to batch. So let me then prover now need to compute the quotient polynomial of f and its opened point Z. Use the formula Q equals to f minus f Z divided by x minus Z. This step, prover need to compute the quotient polynomial. And this step, prover also need to batch the quotient polynomial with the same degree. So I want to draw to illustrate this batch process. This batch process. The lines here, every line means a quotient polynomial. Q. The number I write here means the length of the quotient polynomial, because here we commit the low degree extension of the polynomial f. So the low degree extension, I call it code. So the quotient polynomial we prover commit from f also is a code. So I call this the length of the quotient polynomial. I think, or you can understand what I say. Okay, I will write this. Okay.
It is also the degree of the quotient polynomial.
What?
Is this also the degree of the polynomial?
It should be not totally equal to not equal to the degree, but I can write a formula because in the process of low degree extension, we have the blow up factor. If your degree is like 7, then the blow up factor, if it is 2, then the length of the code will be 8 plus 2. So so this is the relation between the degree and the length. Okay, here means the length of the quotient polynomial. It is equal to the length of the input polynomial f. And now we need to batch the quotient polynomial. Batch the quotient polynomial with the same degree together. It is, I will write it as a inverted triangle. And the subscript here means the log length of the polynomial. So first, we will batch the polynomial has the max degree, max length. Here means Q3 and Q10. Use the random number alpha. So it should be Q3 plus alpha Q10. And next, we will batch the log length, which the polynomial whose log length equal to 7, and will be these three, Q1, Q4, and Q5. Q1 plus alpha, Q4 plus alpha power, Q5. Similarly, I will call this row 一个卷儿 row 8, row 7, and now row 6 should be these two, these three, Q2 plus alpha, Q6 plus power, Q9, and last row 5 will equal to Q7 plus alpha Q8. Okay. I call this process row horizontally because the direction of the batch is this. So I call it row horizontally because later we have the row of another direction. I call it row vertically. Okay. So now, if we need to compute, if prover needs to compute the quotient polynomial, first he needs to compute the open value of f at the open point z. So now prover will send the opened value to verifier. And prover now gets these rules. So I will write it here. But these rules will not send to verifier. A prover now has a set of rules and starts to do FRI. In the process of split and fold of FRI, we also merged the process of rule vertically into it. Like I just said, another direction of rule. So let's start. First, we will take the rule with the max length. It is rule 8. And we do the split and fold. I will write the name or write the length horizontally here. And if we split and fold, now we get P7. The subscript here also means the log length. And now we check in the set of the rule here. Is there any rule whose log length equal to 7? Yes, we found one. Rule 7. So we just add it directly to P7. This is a vector of evaluation. And this also is the vector of evaluation. Both lengths are equal to 2 to power 7. So we just add it item by item. This process is what I said, rule vertically, because the rule direction is this. And now we continue to split and fold. We get P6. And also here is in our set of rule, here is a rule whose log length equals to 6. So we also will add it directly to P6 and continually do this. We get P5 and P4, but we no longer have rule 4, so we don't need to add anymore. And just continually do it. This is the process of FI. To split and fold until we get P1, P0, the constant polynomial. I think I should write the name I said at the start. I call the Plonky3 FRI process roll horizontally and vertically. And or my friends tell me another name, mixed degree FRI. Okay, I will write here. So, in this is FRI. After complete this process, prover gets P8 equal to row 8. And the prover needs to commit P8, P7 to P1 and send this commit to verifier. P8, P7. And the constant polynomial P0 sent to verifier. Now it's a process of answer query. Verifier will send the query index. 这样画，我想一下。这样画一下。Verifier will send the query index R, and prover should respond with the open value of F and the open value of F and P. So it should be F1, F3 opened at R, F10 opened at R, because only the polynomial with the highest degree will open at R, but half the degree is Q1, Q4, and Q5. F1 should open at R power 2. Q, F. Let me write longer. F, and continue to have, we have the degree or length. If you have the length and you also have the degrees, it should be Q2, Q6, and Q9. So F2 should open at R2, which this should be. Could anyone tell me? It should be 4. Until the last one, F7 will open at应该是，对呀，这应该是2.2.2.259 7 8 这没有多少。This is the open value of input polynomial f, and the open value of polynomial p. P will should P7R P1R. Oh, it should be minus. Okay, now with this data, verifier could check the whole process. And we can see verifier need to check three things. First, the correctness of the fold, of the FRI fold. Second, the correctness of this row or this batch. And the third, verifier need to check this row vertically. So verifier many should check these three things. Now let's see how to check. First, verifier need to check open of F at R power. Then verifier need to compute the evaluation of quotient polynomial at the query index R power. Compute the I will write a formula. Compute. I will also write the inverted triangle to denote, because here verifier also needs to use the random number alpha to batch. Compute. Until what? Oh, 5. Until 5. And it should be 7 62的4次方，62的8次方，写出来吧。And the formula to compute this should be F3R plus F10. Oh, no, there is no plus. Minus R.是 F2 吗？完了，写错了。Z3. Yeah, Z. This should be. Z3 means the open point here. The verifier choose for the polynomial of F3 plus alpha F10 R minus F10 Z10 R minus Z10. This is the same as this process, prover to batch, to horizontally to row horizontally. So verifier also needs to do the same process, but use the evaluation sent by prover. This one is sent here, and this one sent here to compute the quotient polynomial, the evaluation of quotient polynomial at R. The rule 7 should open at R power. Okay. So now verifier already compute this. We can get into the process of FRI verify. First, we will check open of check open of this. It will be the rule 8 will combine with P8 minus R. This value is computed by verifier, and this value is sent by prover. And prover and verifier combine these two values together and to use the Merkle-Tree path. Let me write the Merkle-Tree path here. Prover send the open value and also need to send the opening proof, i.e. the Merkle-Tree path. Verifier will check open of these things, use the Merkle-Tree path sent here. Here, the Merkle-Tree path is of a row, and a row is a row has two values. These two values. A row has two values, px and p minus x. In Plonky3, it uses a technique called MMCS to commit a row, not just not a single evaluation, but a row. So here check open also is check open of a row. Later, Triple H will explain these things, about these things. Okay. If the check of this pass, it means row 8x equal to P8x under some sumness error. And also means the batch here is correct. Implies the following check. batch here is Q3R plus alpha Q10R. So in this step, the check open of this path, verifier can check the row horizontally, i.e. this step. Now we do the fold of T7 should equal to this is the formula of the FRI. You can check it in any articles talking about FRI. Minus 2R. This step is corresponding to the prover, the fold of prover in the FRI process. So verifier also need to do this step to compute T7 R to the power 2. And also correspond to the batch here, verifier need to add the row 7 here. And now we need to check open of S7R power and P7 minus R power. And if this check pass, it means applies the following check. S7x should equal to P7x under some sumness error, and P7x R power should equal to T7R power plus row 7R power. And this means we check the correctness of fold and check the correctness of this batch. And these two things plus together, we check the batch here. So the three things both being checked, and we continually to do this until we get S0. And the last check is if S0 equal to the constant polynomial P0, prover just send to verifier. If all this check pass, then it's done. My talk today is over. 感觉大家应该没问题，这样吧。